In this video, we're going to be going over dead loads, which is chapter 3 in the ASCE 716. So first, let's talk a little bit about what are dead loads. Dead loads are any loading or any load provided by something that is permanent or constant. It can't be removed, or it's not intended to be removed from the structure. For example, any framing is going to be dead load. Any of your member self-weights are dead loads. Any flooring are dead loads. Insulation is dead loads. You can find a list of common types of materials in dead loads in the commentary in table C3.1-1A. And I would suggest marking that table because you're going to be calculating dead loads quite a bit. So let's go ahead and go over an example. Let's just draw this up really fast. This actually is the ceiling in the mechanical room of my home. So this is a real example. It's actually not made up this time. All right. So up here we've got 7/8 inch hardwood flooring. Just below that, we've got 1/2 inch plywood. These here, the floor joists, are going to be 2x10s at 24 inches on center. And attached to that, we've got 1/2 inch gypsum board. And then of course we've got HVAC ducts, and we've got some lights with some electrical wiring and such. All right, so now that we've got what our floor system looks like, this down here, as I mentioned, is our mechanical room. And this up here is our living room. So if we're calculating the dead load acting on our living room floor, we're going to go ahead and take all of these separate components and add up their dead loads to get a total dead load. So again, from table C3.1-1A, I always like to start at the top of my system and work my way down. That way I don't forget anything. I like to do all of the different material types, and then I add in miscellaneous stuff like the HVAC and then the lights. That's just how I keep track of it and make sure I don't miss anything. Again, you can have your own system. There's no set rule, whatever works for you. So I'm going to go ahead and start with the flooring, which if we look at that table, we can see that it's divided up into different sections. So the first section is going to be ceiling, and then floor fill, or covering roof and walls, then floor fill, then floors and floor finishes, and then some wood joist floors, frame partitions, and it goes down. So here we've got hardwood floor. So we're going to go to the floors and floor finishes section, and it's going to go ahead and be the third one up from the bottom. So it's 4 PSF for our 7/8 inch hardwood flooring. So now we've got 1/2 inch plywood. So we can go to the coverings section, and as we look down, we're going to find plywood towards the bottom of that, and that's given to us in per 1/8 inch thickness. So we can see that plywood is going to be 0.4 PSF per 1/8 inch. Now we have a 1/2 inch, which we know 1/2 is going to be equal to how many eighths? It's going to be 4. If you can't just come up with that off the top of your head, you can go ahead and set this up as a ratio. And then you just do cross multiplication, so 8 equals 2x, so x is going to equal 4. So we're going to have 4/8. So that's going to cancel out with that. And we're going to get a total of 1.6 PSF for our plywood. Then I'm going to go ahead and go down to our 2x10 floor joists. So if we look in the table, you can come over to the second page of that. It's page 427. And towards the top, there's a section for floors, wood joists, and then there's double wood floor. So we have single wood floor joists. So we're just going to take the value that we get for our 2x10s and divide it by 2. Since these values in the table are for double, but we have single. So again, you go down to your 2x10, our spacing is 24 inches, so that's going to be 6 PSF. But again, we've got to divide it by 2 because in our case, we've got single floor joists, and that's going to be equal to 3 PSF. So now we'll go ahead and look at the 1/2 inch gypsum. Now, this gypsum is being used on a ceiling, so we've got to pull that value from our ceiling section. Make sure you don't pull it from your wall covering section because the values are going to be different because a different amount of plaster is used on the ceiling versus the walls. So go to your ceiling section. It's the second one from the top, and we can see that it's per 1/8 inch thickness again. So we're going to have 0.55 PSF per 1/8. And again, we've got a 1/2 inch, so we've got 4/8. So those will cancel, and we'll be left with 2.2 PSF. Now we can go ahead and move on to our miscellaneous items. So we've got our HVAC. We can pull that value from the table as being 4 PSF. And then we've got all of our electrical wiring and our lights and that type of thing. And that value is not found in the table, but it's commonly in industry going to be 1 PSF. If you've got cases where you've got really heavy lights or a lot of lights, you might want to increase that a little bit to account for that. However, in general cases, it's going to be 1 PSF. So once you've got all that, you just sum all of that up. So the sum of your dead loads is going to equal 4 PSF plus 1.6 PSF plus 3 PSF plus 2.2 PSF plus 4 PSF plus 1 PSF. And you're going to get a total of 15.8 PSF dead load. However, when you're working in industry, you're going to want to work with whole numbers and also take into account that you might have missed something. A lot of times it's hard to account for other stuff that's going on in the ceilings or what might be added to a ceiling. Especially in like garages or something, people like to add something to hang their bikes from their ceiling of their garage or things like that. So you just want to be considerate that, people are going to be adding things. So you're going to want to add in a little bit of collateral load. And this is where it's kind of under your own discretion about how much you add. And again, that's going to depend on what kind of a structure you're looking at. If you're looking at a structure where they're really not going to be adding things to the ceiling, you don't need to add that much. Or if you are very confident that you didn't forget anything, then again, you're not going to want to add that much. But if you're looking at a building that you're doing a design check on and you can't really get up into the ceiling to see what's going on in there, then you might want to add a little bit more. Totally up to your discretion though. But in this case, since we can see into the ceiling, we know exactly what's there. I'm just going to round this up to the next wholest number. So we're just going to say plus our collateral, we're going to have a total of 16 PSF. So our dead load is going to equal 16 PSF. And that's our total dead load for that floor system. And that's the value that we would use in analyzing that system there. And really, dead loads are as simple as that. You pull values from a table, you add them together, you add a little bit of collateral, and there you go. That's it. If you're having trouble, though, feel free to visit our tutoring page or our homework help page. And we'll be able to help you out there and answer your questions.